Okay, so now we're getting into math and matter, or sorry, the matter part of math and matter, and this is part 1. So quickly do the travelogue. Remember, you're just doing true false for the first part, and that's in the before. Leave the after for after. All right, so classification of matter. Matter separates into two different things. You either have a substance or you have a mixture. And there are differences how you can tell between it. So let's go to the substance part right here. So the substance is broken up into two other things. You've got elements or compounds. Whereas mixtures over here are heterogeneous or homogeneous. All right, so we're going to get a little bit into it. Matter is anything that has mass and takes up space. So just about everything is matter. There are two categories, like I said before, substances and mixtures. So substances, they can be elements or compounds. Elements, like the periodic table. Can't really see this one all too well, but yes, periodic table, elements. Compounds, that is elements bonded together at some way. They are always homogeneous. That means if you look at my drink right here, it's blue throughout, it's mixed throughout, it's all even, homogeneous. This would be a homogeneous. Pure, only contain one particle. This is like something separate on its own. If it is called pure, it means it is by itself. Like oxygen. If I say oxygen, I mean all oxygen. All right? Pure, just one particle, one element. And you can write a formula or a symbol for a substance, like NaCl, that's salt, that's sodium and chlorine, or dinitride, two nitrogens, nitrogen. All right, so elements, they're the simplest form of matter. They can't be broken down into anything smaller. That's it. Like it breaks down just to that. You can't get any further. They're the building blocks for compounds. And you can write these symbols as like Au, which is gold, Cl, chlorine, He, helium, etc., etc., etc. The smallest unit of an element is called an atom. So right here, you see a bunch of dots, which are, in this case, considered an element. They're monoatomic elements. And then you see this one right here. These are two elements together, the same type together, and they're called a diatomic element. We'll get into those when we get into the periodic table, but there are diatomic elements. Okay, so compounds. Compounds are two or more different atoms chemically, not physically, chemically combined in a definite ratio, which means the composition is definite. There is a certain number of this and there's a certain number of this. That is the definite ratio. Okay? It will not vary from sample to sample. It will always be the same throughout. Must be chemically separated into elements. It can't be physically separated, chemically separated. The smallest unit of a compound is called a molecule. So remember, if we go back, the smallest of an element is an atom, smallest of a compound is a molecule. Separations of a substance. Elements can't be broken down any further. It just can't. Compounds, however, can be chemically separated. For example, electrolysis of water to produce H2O, or H2 and O2, so hydrogen and oxygen. Mixtures. So what are mixtures? They are two or more substances that are mixed up, and they can be separated physically. They can be homogeneous or heterogeneous. The composition is not defined. There's not a certain number of this and a certain number of this. It will vary from sample to sample. So let's look at homogeneous. They have the same uniform composition, like gas mixtures. They're all combined. And I have an example right here if I can get them all to stay together. Oh my gosh, they're going everywhere. Never mind. I'm not going to get them all. I definitely am not going to get them all. They're all over the place. So a homogeneous mixture, gases. And if you've ever seen my desk and they're flying all over the place, I do apologize. On my desk, I have all these lovely little magnets. They're all the same type. This would be considered a homogeneous mixture. They're a mixture of all these beads that they're same size, all here. This is homogeneous. The particles of a homogeneous mixture are evenly mixed, so it looks like only one substance is present, right? Although that's not the best case of homogeneous, but the stuff on my desk. Think of homogeneous as also your Kool-Aids. When it's mixed properly, everything is homogeneous throughout. You can't tell the difference between the two. What's water, what's your Kool-Aid mix. A mixture is not the same throughout and can be seen, the parts can be seen. For instance, Kool-Aid, just like I said, salt water, tea, all solutions, which are going to be denoted as an AQ, mean solution. So NaCl, that is a solution of salt water, sodium chloride. Heterogeneous. Samples have a varied composition. The particles of a heterogeneous mixture are unevenly distributed and appear separate as separate components in a mix. So if I put my paper clips with this is a heterogeneous mixture. The different parts are visible. I can see the different parts. Oops, lost another thing. I can see the different parts of this. You can see where the balls are. You can see where the paper clips are. I can pull them apart. So examples of this would be like pizza, sand, sand and water, salads, chocolate chip cookies. All right, so we're going to go to our worksheet and classify a couple things. So tell me, is this substance a compound or an element? Or is it a mixture? If it's a mixture, is it homogeneous or heterogeneous? What is the basic structure? Is it an atom, a molecule, or both? All right, so that's it for today. If you have any questions, please do not hesitate to email me and let me know. All right? I hope you guys have a great day, and I'll talk to you later.